Hello, 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 hello. Am I audible? Let me know if I'm audible or not. Hello, 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 hello. Divya Jyoti Ghosh. Yes, beta. Divya Jyoti Ghosh. Yes, beta. बहुत बढ़िया आप सुनाइए। और आरुषि भी देख रही है लेक्चर को, है ना? बहुत बढ़िया आप सुनाइए। आरुषि भी देख रही है लेक्चर को, है ना? चलिए स्टार्ट करते हैं आज का लेक्चर। चलिए स्टार्ट करते हैं आज का लेक्चर। चलिए, I think we need to start the lecture now. Okay. 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 Just because of some different stuff is to be done, I had to just reschedule my class. And I think this one is feasible, right? Feasible, right? To have the classes after 10 p.m. No, it is a feasible for all of us. Hello, Ritika. Hello, hello. Okay, let's start the class now. Start the class. Okay. So we are having the chapter known as units and dimensions, and it will take 2 to 3 hours to get complete from very basics. If you haven't studied a single thing of this chapter, I am going to start from the very basic, that means from zero up to the your desired level, whether you want from boards for G for your need. Okay. Okay, now look, first thing that we are having, so we are having our physical quantities. We are having physical quantities. Now, what is basically a physical quantity? The same thing I have discussed in the previous chapter, that is vectors, what physical quantities are. So I can write now those quantities, simply those quantities which can be measured, and used to describe the law of physics. So any quantity which is measurable and used to describe the laws of physics, those quantities are known as physical quantities. Suppose we are having force is equals to mass into acceleration. Mass is measurable, force is measurable, acceleration is measurable. That means all these quantities are physical quantities. Okay, now first thing we are having, first thing that we are having, okay, now we are having classification. Classification. Classification on the basis of, on the basis of directional properties. That means we are having some quantities in which direction plays an important role, and we are having some other quantities in which there is no meaning of having the direction. That means we are having physical quantity. We are having physical quantity. So some physical quantities, one type of quantity is known as scalar physical quantity, and second type of physical quantity is known as vector physical quantity. Scalar quantities are those quantities in which only magnitude is present. Magnitude only. And vectors are those quantities in which magnitude in which direction and laws of vector should be obeyed. Okay, scalar means only magnitude present, vector means magnitude, direction, and laws of vector should be followed, obeyed. Quantity. So in scalar we are having mass, in scalar we are having distance, we are having density or current, etc. These all are scalar physical quantity. If we are force, displacement, velocity, all these are in which direction plays a very important role. So all these quantities are known as vector physical quantities. Clear now? Okay. Now we are having second type of classification. Classification on the basis of dependency. On the basis of dependency. Okay. So some physical quantities are independent on each other, but some quantities are which are dependent on one another. Look now. So we are having two types as well in this kind of classification. One is known as fundamental. Fundamental or base physical quantity. One is known as derived. Derived. Fundamental means it is that type of physical quantity which is independent of each other. And derived physical quantity means dependent on each other. Dependent on each other. So some physical quantities are derived and some physical quantities are fundamental or base physical quantities. Clear? So which quantities are fundamental or base quantities and which quantities are derived quantities? So in the whole physics we are only having seven quantities. We are only having seven quantities in which we are having mass, length, time, temperature, current, amount of substance, luminous intensity. Luminous intensity. These quantities, these physical quantities, whether mass, length, time, temperature, current, amount of substance, and luminous intensities. These seven quantities in whole physics, these quantities are independent of each other. That means mass is not having any factor of length to get it is meaning. We know that what is mass. So in mass there is a 0% involvement of length. In the same way, in temperature, there is no involvement of length to define it. So these are those quantities which are sufficient for its meaning, which doesn't need the help of mass or help of length or help of one another to get its meaning. Those physical quantities are fundamental or base quantities. And derived quantities are those quantities in which minimum two base quantities are involved. Let us suppose we are having speed. I think speed is nothing but distance by time. Speed is distance by time. So what is distance? I think distance is length and time is time. So to get the meaning of speed, we should know what is length and we should know what is time. So speed depends on length and speed depends on time. That's why speed is a derived quantity because it depends on the fundamental or base quantities. So that's why it depends on the fundamental or base quantities. So you can say that except these seven quantities, all other quantities. I think there's a lag, right? Now look, what is force? Force is mass into acceleration. Mass into acceleration. So mass, I can write mass as it is mass. and acceleration is velocity by time. Velocity by time. Or I can write it as a mass into velocity. Velocity is displacement by time. That is displacement by time square. So I can write it as a mass into length by time square. So to get the meaning of force, we are having mass, we are having length, we are having time included in it. So that's why force is a derived quantity. Yeah, also density is a derived quantity, right? Mass per unit volume, if you are considering about the mass density. So it is mass per unit volume. If we are having energy density, energy per unit volume. So if some quantities are depending on other quantity to get its meaning, so all other quantities are known as the derived quantities. Okay. Same way, what we are having, which example did this student give me? That is density, right? So I can write density also. Density. What is density? Mass volume. Mass is mass, volume is length cube. So this the density is also a derived quantity. Now, if we are having some physical quantities, now we want to measure those physical quantities. We want to measure its magnitude. Okay. So over the past centuries, we were having different types of units to measure these quantities. So some of the systems are. So I can write now system of units. System of units. So basically, we were having three major types of units in which we were calculating or measuring the magnitude of these physical quantities. So we were having three. We were having three. One was FPS, one CGS, one MKS. So we were having what? Length, mass, time. So these three quantities were being calculated by using these kinds of systems. So length we are having in FPS, we are having for length foot, mass pound, time second. In CGS we were having centimeter, centimeter. For mass we were having gram. For time we were having second. In the same way in MKS, for length we were having meter, mass kilogram, time second. So these were three important system of units in which we were calculating the magnitude of length, mass, and time. But over the period of globalization, these three kinds of system of units get discarded because it gets very hard for people to convert these kind of system of units for their business. So at the end, scientists introduced a universal accepted a unit known as international system of unit. So at the current scenario, at the current time, we are having a different type of unit known as SI unit. Very important for our physics, known as international system of units. International system of unit. Clear? Now, what we are having in the SI system of units. So we are having mass, same length, time, temperature, current, luminous intensity, amount of substance. Amount of substance. Yes, because different parts follow different types of unit. So let us suppose if we are in India now, we want to go to the British and have the kind of business. So we were had the kind of calculation of our stuff, and we just have kind of budget. No, we can bargaining at that particular level. But when we go there and had the kind of bargaining, so we don't know what kind of system they are following. So to get the kind of confusion clear, so there were a need of the latest sort of unit system. So scientists introduced a international of system of units. So the unit for mass was, or it is, a kilogram. In length, it is meter. For time, it is second. Temperature is Kelvin, and current is ampere. Luminous intensity is candela. Amount of substance is mole. Clear? And kg represented as kg, simple kilogram. Meter as small m. Second as s. Kelvin as k. Ampere as a. Candela as cd. Mole as mol. I think we know that, no? We know that the kilogram mass second, this thing came from the mks. So we were having what? The third type of unit, mks. So I think we need to write it as a mks, and these four are additional. These four are additional. These four are additional. So you can also state that these four are additional. Yeah. So these four are additional. So you can also conclude that SI system, we are having it from the MKS. So we have added four different kinds of physical quantities in MKS, and we called it as a SI system of units. Easy, no? Now we are having now base units. Base units means the units which describes or which explains the base quantities. I think these seven quantities are base quantities. So these seven representation, these are units of base quantity. So I can write those as a base units. These are base units. Units which is with the base quantities, those units are known as base quantities. I will be sharing the notes in the Telegram group, right? After completion of this chapter, I will be sharing. Don't worry. Now, so we are having now derived units. We are having now derived units. Derived units means units which we are having with the derived quantities. So we were having speed. We were having speed. So speed is nothing but distance by time. So distance is length. So I can write it as a length by time. So length is meter, time is second, so meter per second. So the unit for speed is meter per second in SI unit. In the same way, I can write it as a m divided by s or ms inverse. Second, we are having force. Force is equals to mass into acceleration. You can search for Shukur sir physics, right? And you will get. Arashi, you can share the Telegram link, no? You can share the Telegram link. Now look, so it is mass into acceleration. Mass into acceleration. So mass is kg. Acceleration is what? Length. So we are have now we discussed it. It was length divided by time square. So I can write it as a kilogram meter second square or kgm s minus 2. So one more density. So density equals to mass by volume. Mass is kg and volume is length cube. So I can write it as a kg meter cube or kg m minus 3. Clear? Apart from these kinds of units, whether my fundamental, my derived, we are having some supplementary units as well. We are having some supplementary units as well. Supplementary units. In supplementary units, we are having two different types of quantities. One plane angle, B solid angle. Plane angle means 2D angle, solid means 3D angle. Why we are kept it in a supplementary thing? Because these are those units, these are having the unit but not dimensions. Clear? So if we are having one like this and we revolve it like this, initial, this one is final. So this sort of thing is known as angle, and the displacement of the or the distance traveled by the tip of this line is known as arc length. This is arc length. This one is radius. Why? Because it will become a circle after completing one revolution. So we are having a formula. Arc length is S. So we are having a formula S is equals to R theta. S equals to R theta. Clear? So second is a solid angle, which is not important. So in theta, we are having, let us suppose we are having some omega, and in the place of R, we are dealing with the area. This one is not that much important. Plane angle is important for us. Plane angle is very important for us. Okay? Plane angle is one of the important for us, one of the important parameter for us. And give me 1 second, having some now. So we are having some different types of units as well. So we are having some improper units as well. Improper units. So we are having kilogram weight, we are having gram weight, we are having these two things, no? Majorly these two things are there. Or we are having kilogram force or gram force. So these are practical units of force, right? These are practical units of force. Kilogram weight, gram weight. Kilogram weight is 9.8 Newton, gram weight is 980. Just like kilogram force is 9.8, gram force is 980 dyne. Okay. Now, so we are having two parts of our chapter, units and dimensions. So we have completed our units now. We will go on to start the dimensions one. Any confusion up to now? Any confusion now? We have completed one portion of our syllabus, that is a units one. Now we are going to start the dimensions. Which one? Which one, Arushi? Supplementary units These units are having the units but not the dimensions. Okay. Now, going to start dimensions. Going to start dimensions. Now, what basically dimensions are? So, for any physical quantity, the dimensions are the powers of our base quantities that is used to describe that physical quantity. Okay, so I will write the definition of it so that you can have for your revision portion. So of a dimensions of a physical quantity, dimensions of a physical quantity are the power to which the base quantity are raised to express that quantity. Which one then? Supplementary, the improper units. So look now, we are having kilogram, kg. So kg represents mass, but kilogram weight represents force. So these are some different physical quantities. They define some different physical quantities as their name. That's why we called it as a improper units. Now let us suppose, let's take an example now to get the dimensions clear. So we know that one quantity, that is volume. Volume. So to describe volume, we need length. We need length multiplied by breadth multiplied by height. Length is measured in meters or length. Simply length, I can write it as a length. I think breadth is also a length and height is also a length. So I can write it as a length cube. So to get the meaning of volume, I need to describe the volume in length. By how many times? By 3 times. So 3 is the dimension of length. Yeah, perfectly. So 3 is the dimension of length. So same we are having area. So to describe the area, we need length by 2 times. So 2 is the dimension of length to describe the area. Clear? Clear? Easy, no? Now look, we are having now, we are having now, we are having dimensional formula. We are having now dimensional formula. Just give me a second. Okay, now what is dimensional formula? So dimensional formula is an expression which gives you the information that how your physical quantity is depending on the base quantities and how many times. So I can write the definition first. So it states that the dimensional formula, the dimensional formula of any physical quantity is that expression which represents how and which of the thank you, beta. So the dimensional formula of any physical quantity is that expression which represents how and which of the base okay base quantities are involved in that quantity in that quantity. So the dimensional formula of any physical quantity. So the dimensional formula is an expression which gives you the information how or which base quantities are involved in giving the meaning of your quantity and how many times. Let us suppose we are having mass. Let us take the example of mass. We are having mass. So we are having 7 different physical quantities now. So we are having mass, we are having length, we are having time, current, temperature, luminous intensity, amount of substance. Amount of substance. So I think mass is only depending on this mass. Mass is only depending on mass. That's why it is a base quantity. So I can write what I can write. I can write mass. I can write mass. Mass is depending on mass. How many times? 1 times. I can write and place a square bracket. So this is a dimensional formula of mass. Or I can write it as a mass depends on m by 1 factor, L by 0, that means it is independent on L, and T0, it is independent on time as well. So the dimensional formula of mass is M1L0T0. Okay, we will do some numericals, we will do some problems as well. No? So if if we equate, if we equate physical quantity with its dimensional formula, we called it dimensional equation. That we are equating the we are equating the physical quantity with its dimensional formula. So the same example I will take here, mass. So if I equate mass which is a dimensional formula m1l0t0. So this thing is known as dimensional equation. So this thing is known as, I can just place into a box. So this thing is known as dimensional equation. Dimensional equation. Now we will do maximum number of dimensional formulas from 11th physics and 12th physics. Okay, all important physical quantity dimensional formula we will derive here. So be attentive, be present to. Now look, we are having speed. Same. What is speed? It is distance by, I can write it as distance by time. Distance is length. Time is time. So length means L. Time means T. So I can write it as a m0 L1 T minus 1 or L1 T minus 1 or simply LT minus 1. So what would be the dimensional formula of acceleration? So it is basically velocity. Velocity by time. Also, it is length by time square. So length is L, 1 times time is T 2 times. So I can write it as a m0 L1 T minus 2 or I can write it as a LT minus 2. Now we are having force. Force is mass into acceleration. For mass we are having m. Mass 1 times acceleration is LT minus 2 or like this, or I can write it as a MLT minus 2. MLT minus 2. Clear? So for work, what is work? Work is force into displacement. Force into displacement. Force we are having MLT minus 2. Displacement means length, it is L. So I can write it as a ML2T minus 2. Okay? It is work, no? It is work. It is work. Same we are having energy. The dimensional formula of energy is same as of the work. It is ML2T minus 2. How you can write the energy of the dimensional formula of energy 1 ML2T minus 2? Let us take the example of kinetic energy. Let us take now. Look now. Let's say example of it now. Okay. So let us take, we are having potential energy, we are having kinetic also. I can take kinetic now, 1 by 2 mv square or mgh. I can write mgh, potential energy. So what is m? M is capital M. G is acceleration due to gravity. It is acceleration. So what is the dimensional formula of acceleration? I think it is LT minus 2. What is h? H is length, so it is L. So I think it becomes ML2T minus 2. So if I do the also kinetic one, 1 by 2 mv square. 1 by 2 is a dimension because it's a constant term. So mass m is m. What is L? L is LT minus 2. Sorry, LT minus 1. It is LT minus 1 and whole square. So I can write it as a ML2T minus 2. Okay. Now we are having power. Now we are having power. We are having a power, right? Power. What is power? Rate of doing work. So I can write it as a work by time. Work by time. What is the dimensional formula of work? It is ML2T minus 2. Time is T. So I can write it as a ML2T minus 3. ML2T minus 3. Now we are having pressure. We are having pressure. What is pressure? Pressure is force per unit area. So force we are having MLT minus 2. Area is L square. So I can write it as a ML minus 1 T minus 2. We are having frequency. We are having frequency. What is frequency? 1 upon time. So it is 1 by T. It came out to be T minus 1. We are having wavelength. I think wavelength is the displacement. Okay, so it is length. We are having amplitude. What is amplitude? The maximum displacement from your mean position. So it is also L. Yeah, from the basic formula, we can get dimensional formula of whatsoever quantities you are having. You can wait now. We will do couple of numericals. We will do couple of things. And if time permits, we will complete whole 11th, whole 12th important uh, derivations of the dimensional formula. Amplitude. Now we are having energy density. We are having energy density. So what is energy density? It is energy per unit volume. Energy per unit volume. Energy is how much? ML2T minus 2. Volume is L3. So I can write it as a ML minus 1T minus 2. We are having gravitational force. We are having gravitational force. Gravitational force simply means force. So I can write it as a MLT minus 2. ML T minus 2. Clear? We are having universal gravitational constant. Once again. Now we are having universal. Spelling is wrong. Universal gravitational constant. Universal gravitational constant. So I think we are having equation that is F is equals to G m1 m2 by r square. So from this what we can get now? So I think my G is equals to Fr square whole divided by I think G m1 m2. Now look what is force? It is mlt minus 2. R is length, it is L square. It is not here. We are not having G, no? So m1 m2 it is m into m into m, that is m square, m into. So I think we can write it as a ml3 t minus 2 divided by m square. I can write it as a m1 minus 2. It is m minus 1 l3 t minus 2. This one is the m minus 1 l3 t minus 2. So I can write here now m minus 1 l3 t minus 2. Okay, we are having orbital of escape velocity. Escape velocity. So basically, it is a type of velocity. So its dimension would be equal to the dimensional formula of velocity Lt minus 1. Okay. Now we will move ahead to the angular portion one now. Now dimensional formula of angle. So angle R, we know S is equals to R theta. So now I think I can write theta is equals to arc length. Arc length by radius. Arc length is length, that is L. Radius is also L. So we will get m0 l0 t0. So the dimensional formula of angle is a dimensionless quantity. Angle is a dimensionless quantity. Now we are having angular velocity, omega. That is the angular displacement omega theta by t. I can write it as an angle by time. Angle is a dimensionless quantity, so I can write m0 l0 t0 divided by time t1. So I can write it as a t minus 1. So the dimensional formula of angular velocity is same to that of the frequency. Okay, so we are having some numericals like this in our NEET examination, that which of the following are having the same dimensional formula. So here we can conclude that the dimensional formula of angular velocity is same as that of the what? Frequency. Now we are having angular acceleration. Angular acceleration. So I can write it as an angular velocity. Angular velocity by time. So angular velocity is nothing but t minus 1 whole divided by t1. It becomes t minus 2. So now we are having tangential acceleration. Tangential acceleration. Tangential acceleration is dv by dt or alpha r. Okay. So it is acceleration, it is LT minus 1. Yes, for need it is something that may be asked in your examination. So you can have your PYQs and you can find every year there is a one numerical based on the dimensional formula. So now we are having torque. What is torque? It is force multiplied by perpendicular displacement or distance. Force is mlt minus 2. Distance is L. So it is ml2t minus 2. So the dimensional formula of energy, the dimensional formula of work, and the dimensional formula of torque is same. Okay, so you can say the dimensional formula of this is same to that of the work and energy. We are having moment of inertia. I. Equation is mr square. M is mass. It is L square. So ml square. We are having angular momentum. We are having angular momentum. L, which is mvr. Mass is m. Velocity is lt minus 1. And the r is L. So I can write it as a ml2t minus 1. We are having the radius of gyration. A radius of gyration, it is nothing but L. You don't need to remember these things, no? You have to focus on the basic equations of your parameters. Then you can derive it. So I'm just giving you the information how you can derive it then. We will start the thermal physics now. Now we are having heat current. We are having heat current. I think heat current is heat by time. Heat by time. And heat is a some form of energy. So it is ml2t minus 2. Time is t. So you can write it as a ml2t minus 3. We're having thermal conductivity. Thermal conductivity. So it is basically H, which is equals to Ka delta T whole divided by L. So how K, we can write the K is HL divided by A delta T. What is H? H is heat current, that is ml2T minus 3. What is L? L is length, that is L. Area, that is L square. Temperature, we are having Kelvin. I can write it as a mll2 1 at m1 T minus 3 K minus 1. Dimensional formula of thermal conductivity. We are having specific heat capacity. Specific heat capacity. It is delta Q, which is equals to ms delta T. So what would be the dimensional formula of S? S would be delta Q divided by M delta T. Q would be mL2 T minus 2, a form of energy, and M is mass, M and temperature is Kelvin. So I can write M0 L2 T minus 2 K minus 1. We're having solids. Now what is dimensional formula for citrus? Citrus is force per unit area, same as the pressure. So it would be mLT minus 2. Area is L square. So I can write it as a ml minus 1T minus 2 whole divided by L square. Oh, no, it is not like L square, no? Okay, now we are having strain. Strain in change in length by length. So I can write L by L. So it is a dimensionless quantity. Strain is also a dimensionless quantity. Now we are having Young's modulus. We are having Young's modulus. Young's modulus is stress-based strain. Citrus dimensional formula is ml minus 1T minus 2. Strain in dimensionless quantity. So the final dimensional formula of Young's modulus is ml minus 1T minus 2. Okay. Now we are having charge. Charge is current into time. Current is ampere, time is T, so it is 80. What is electric field? This one is for 12th portion. What is electric field? Electric field, that is F, which is equals to Q times E. So I can write my E is equals to F times Q. F is force, that is mLT minus 2. Q is charge, charge is 80. So I can write it as a mLT minus 3A minus 1. Now we are having electric flux. We are having now electric flux. Electric flux is EdA cos theta or simply E into A. A is area, E is electric field. So what is E? E is given as mLT minus 3A minus 1. What is area? Area is L square. So I can get it as a mL3T minus 3A minus 1. Now we are having electric dipole moment. It is charge, either charge into the length. So I can write it as a Q into length. Q is charge, that is A into T, current into time. Length is L. So I can write it as a M0 L1 T1 A1. We are having voltage or potential difference. So we are having equation V equals to IR. We know that R, we don't know the dimensional formula of R, so we can't use the equation of V equals to IR. Now one more, we are having P is equals to V square by R. Same, we need power we know, but we don't know the R. One more, we are having V is equals to W by Q. So W we know, Q we know. So this formula we can use to get the formula. So what is W? It is work done. That is mL2T minus 2. What is Q? Q is 80. So 80. So my final answer is ML2T minus 3A minus 1. Now I can get the dimensional formula of resistance also from here. So what is the resistance? No, V equals to IR, so R is the resistance. So resistance is equals to power equals to I square into R. Or I can write it as a resistance. Okay, resistance. So I can get it as a right, power by R I square. So power is what? I can done it into the work done terms also, right? So I can write the work done divided by time into I square. So what is W? It is ML2T minus 2. Time is T. Current is A square. It would be ML2T minus 3A minus 2. Dimensional formula of resistance. Now we are having magnetic field. We are having magnetic field. So magnetic field is F equals to current into length into ILB, magnetic force I into L into B. So what is B? B came out to be F divided by IL. What is F? F is force MLT minus 2. Current is A, length is L. So I can write now M. Okay, length is L. Here we are having L now. We are having L. So ML0 T minus 2 A minus 1. Now look, we are having magnetic flux. We are having magnetic flux. So magnetic flux is magnetic field into area, same as the magnetic electric flux, E dot A. So what is B? B we know that it is MT minus 2A minus 1. Area is L square. So I got ML2T minus 2A minus 1. Now we are having permittivity constant. Permittivity constant. That is epsilon naught. So Coulomb law is equals to 1, F equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. So I can write epsilon naught would be equals to 1 divided by 4 pi F charge square divided by R square. So I can write 1 divided by MLT minus 2. Charge is how much? It is current into time AT. So I can write it as a current. It is AT. It is A square T square. Whole divided by it is L square. So it would be equals to M minus 1, L minus 3, L minus 3, and T is T4. T4 and A is 2. It is A2. Same, we are having dielectric constant also. We are having dielectric constant. We are having dielectric constant. That is K, which is equals to epsilon naught divided by E net. So same quantity, so we are having L0T0. Now we are having permeability constant. Permeability constant, which is equals to nu naught. It would be equals to force per unit length. Equation we are having, it would be equals to nu naught I1 I2 whole divided by 2 pi r. So what would be nu naught none? So nu naught would be equals to f 2 pi r whole divided by uh, L I1 I2. So f is nothing, it is force ml t minus 2. 2 is nothing, pi nothing, r is L whole divided by L is length L, current is A, it is ampere into ampere. So what I can get, it is m LT minus 2 A minus 2. We are having one more way to get it now. How? Because we know that c speed of light is equal to 1 divided by under root of epsilon naught nu naught. Also from this equation we can get the answer. One last, we are having Planck's constant. Planck's constant. It is E is equals to h nu. So that means h is equals to E by nu. Nu is a frequency. What is E? It is energy. It is ml2t minus 2. Nu is a frequency. What is frequency? It is time. 1 by time. So it is time inverse. So I can write it as a ml2t minus 1. So I think we have now derived each and every possible major dimensional formula of physics, whether it is 11th or 12th physics. Okay, we have derived how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I think more than 40 dimensional formulas we have discussed and derived now in this class. Now we are having some rules for dimensions. We are having some rules for dimensions. All right. Rules of dimensions. Rules of dimensions. Very important. Very important. How? Because look, first rule states that only same dimensional physical quantities can get added or subtracted. First rule. First rule states that only same physical quantities can be added or subtracted. That means if we are having something like this now, we are having A plus minus B. This is only possible when we are dealing with mass. So mass can be added or subtracted with mass. Length can only get subtracted or added with length. Time with added or subtracted with time only. Okay, the same quantities can get added or subtracted. If now in some numericals we are adding or we are subtracting something, so you have to keep this thing in your mind that those physical quantities, those should be the same. Those physical quantities should be the same. Second rule. Second rule. If physical quantities are multiplied or divided, then a new physical quantity is formed. New physical quantity is formed. That means if we are doing A multiplied by B or A divided by B. Okay. If we are doing A into B or A by B. So A and B, these may be the different. Okay. So why we are having these rules now? So let us suppose we are having mass. So we cannot add mass to length or time, and we cannot subtract mass length time. That's why we only added or we only subtracted the same quantities. So in we are dividing or we are multiplying, so we will get a different physical quantity. Let us suppose we take an example now. Suppose okay, suppose if we are having mass or we are having length, we are having time. So we got a quantity known as length per time. It will be a different quantity. It is a speed or velocity. Okay. Now we are having now dimensionless quantities. We are having now dimensionless quantities. We are now having dimensionless quantities. Firstly, a ratio of physical quantities with same dimensions. Suppose we are having angle. Angle is equals to arc length by radius. Arc length is length, radius is length. So what we get? We get a m0, l0, t0. So we get a dimensionless quantity. Same, we are having strain. We are having strain. Strain is change in length by length. So what we will get? We will get nothing. Dimensionless quantities. If we are dividing a similar physical quantities, no, we will get a dimensionless quantity. We will get a dimensionless quantity. Second, all mathematical constants. All mathematical constants. All are dimensionless quantities. Third, all standard functions and their inputs. Let us suppose we are having some exponential functions. We are having some logarithmic functions. We are having some trigonometric functions. We are having some inverse trigonometric functions. Okay. All the things are dimensionless quantities. So that means if we are having exponential something upside is a dimensionless quantity. If we are having log and we are having something dimensionless quantity. If we are having some sine and the argument of sine, dimensionless quantity. If we are having cos inverse and the argument of it, a dimensionless quantity. All are these are the dimensionless quantities. Let's take some numericals. Let's take some numericals. Okay. Let us take some numericals to get it done. Give me 1 minute. I need only 1 minute from your side. Only 1 minute, right? And we will do some numericals to get this thing clear. Then we are having errors, then rounding off, then significant figures, and that's it. Let's do a numerical. We'll do a numerical. Do a numerical. Now look, we are having a numerical, that is A is equals to Vt plus B divided by X minus C. We need to find the dimensional formula of A, B, and C. Firstly, we know that if we have done X minus C, that means the dimensional formula of X and the dimensional formula should be same. So I can get an idea from it now. So the dimensional formula of X is equal to dimensional formula of C. X is length. So C we get it as a length. Clear? Now if we are adding Vt with this thing, now so the dimensional formula of Vt should be equal to the dimensional formula of B divided by X by C. So I can write then dimensional formula of A, it should be equal to the dimensional formula of Vt, and it should be equal to the dimensional formula of B divided by X minus C. So A, what is V? V is a velocity. So I can write Lt minus 1 and time as a time t. It is equals to, here it is equals to. T get cancelled out. The dimensional formula of A came out to be L. Now look, we are having B divided by X minus C, that is L only. It is equals to L. Dimensional formula B came out to be L square. Okay, now one more numerical. One more numerical. If we are having F, it is equals to A log Bx. We know that whatsoever is written inside the log, that is a dimensionless quantity. So I can write like this now. Here Bx is equals to M0 L0 T0. So B, what is X? X is a length, so I can write length L. It is equals to M0 L0 T0. So my B came out to be L inverse. So the dimensional formula of force, it should be equal to the dimensional formula of A. So what is F? F is force, that is mLT minus 2. It is equals to A. It is equals to A. Clear? So now we are having a differentiation and integration. So I can write now dimensions in calculus. Dimensions in calculus. Now look, we are having two things here. First is we are having differentiation. I will do the differentiation part firstly. So if differentiation is dny by dxn, so if you want to get the dimensional formula of it, no? So it is dimensional formula of y divided by x to power n only. Y divided by x to power n only. Let's take up an example to get it clear. If we are having d square y by dt square, so I think it would be y divided by time square. Y is length, so I can write length by time square. So I can write it as a LT minus 2, that is a acceleration. So this is the acceleration. A representation of a acceleration. So d square y by dt square is the acceleration. One more. If we are having dm by dt, to get it is dimensional formula. So the dimensional formula will be equals to m by t only. M is m, t is t minus 1. One more. If we are having d6x by dt6, yeah, I will do now. So in the application part we will do. In the application part, it will take 2 minutes, and we will can do that portion as well. So it is d6x dt6. So I think my answer would be x divided by t to power 6. It would be x is length divided by t6, or lt minus 6. Now we are having integration. We are having second, that is integration. We are having some integration. So what is the representation of integration? It is y dx. Integration of y with respect to dx. So it is dimension is only yx. Let's take a numeric question to get it clear. Integration of v dt. It is only vt. What is v? V is velocity, that is lt minus 1. Time is t. So we will get only L. If we do the integration of velocity, we will get a displacement, that is L. Now we are having application of dimensional formula. Application of dimensional formula. Application of dimensional formula. First application. What is the first application of dimensional formula? So it is first application is to convert a physical quantity from one system of unit to the other system of unit. Okay, first application part. To convert a physical quantity, to convert a physical quantity from one system of unit, one system of unit or units to other. We know that now. Let us suppose I will give you an example whether 1 kg of something is bigger or 1000 gram of something is bigger. 1 kg of something is bigger or heavier or 1000 grams of something is heavier. You can say that both of these quantities are same. The magnitude of 1 kg of something is equal to the 1000 grams of magnitude of something is same. So whatsoever units we are having, magnitude always remains same. Magnitude always remains the same whatsoever quantities we are having. So what we can write now? We can write magnitude. We can write magnitude is equals to numerical value or numerical value, that is n multiplied by unit, which is u. It is always constant. It is always constant. So I can write n1 u1 is equals to n2 u2. How? So I can write example now. 1 kilogram is equals to 1000 gram. So 1 is a numerical value n1, kg is u1, n2 is 1000, u2 is g. u2 is g. If we are having some quantity which is expressed in its base term, that is mlt. So how we can do it now? Look, my n2 is equals to n1 u1 by u2. So I can write it as a n1. What is u1? u1 is a unit of system. So we are having, what we are having in units, we are having mlt. So I can write it as a m1a, l1b, t1c. Okay, divided by m2a, l2b, t2c. So I can write it as a n1 m1 by m2 whole power a, l1 by lt whole divided by b, whole power by b, t1 by t2 whole power by c. This is important thing that we need to have. Let's take an example to get it clear. Example, huh? Convert 1 Newton into dyne. 1 Newton in dyne. So firstly, we know one formula, that means n1 u1, it should be equals to n2 u2. What is n1? n1 is 1. n2 we need to find out. u1 u2 we know. Wow. u1 is the unit of force in SI system. Dyne, CGS unit of force. Okay. Now what is force? What is force? Force is mlt minus 2. So now we are having an equation. No? We are having an equation. So I can write N2 is equals to N1 U1 by U2. So I can write it as a N1 M1 by M2 into A L1 by L2 power B T1 by T2 power C. Now place the values. What is N1? N1 is 1. What is N1? N1 is 1. M1 mass, the unit of mass in SI system, it is kilogram. So I can write kilogram. M2 is in the CGS, it is gram. Whole power A is how much? It is 1. M1, it is 1. L1 is, what is the unit of? What is the unit of length is SI? It is meter. In CGS, it is centimeter. And it is 1. T1, it is second, divided by it is second. And power is minus 2. It is given now. 1, 1 minus 2. So now look, 1 is 1. So I think in 1 kilogram, we are having 1000 gram. Gram is gram and 1 is 1. 1 meter, we are having 100 centimeter. 100 centimeter, we are having 1 meter. So 100 centimeter, centimeter. 1. Second, we cancel out. So we are having 1 minus 2. It is only 1 only. Gram, cancel. Centimeter, cancel. So I can write it as a 1. 10 to power 3. 10 to power 2. 1. So we got it as a 10 to power 5. So therefore, 1 Newton is equal to 10 to power 5 Diane. Any confusion, Ritika, now? Any confusion now? Hmm? One more numerical. We'll do one more numerical. One more numerical. Convert 0.5 gram per centimeter square to SI unit. To SI unit. This one is our numerical. Now look, this is N1, this one is U1. SI is U2. N2 we need to find out. So N1 we are having 0.5. U1. In U1, my mass is given in kilogram. Sorry, gram. It is centimeter and it is length. So my length is given in centimeter. So N2 we need to find it out. So what would be the mass in my SI unit? It would be kilogram. And my length would be in meter. So we are now having the formula, sir. N2 is equal to N1. M1 by M2 power A. L1 by L2 power B. T1 by T2 power C. Now we are not having any time here, so there is no useful of no term that is we can involve in the time t. So how we can do it now? What is N1? N1 is given as 0.5. M1 is given as gram. M2 is given as kilogram. And A is given as, we don't have anything on the G now, it is only 1. L1 is given as centimeter. L2 is given as meter, but it is given as 2. It go upside, it become minus 2. It is given as minus 2. Look now. Okay, I will take this one here. So it will, I can write 0.6 gram centimeter minus 2. Okay, this one is my M1. It is L minus 2. That's why I have written this thing like here. I can write 0.5 in gram. So if we are having 1 gram, so in kilogram, how many grams we are having? 1000 grams. So I can write 1000 gram. Power 1. Centimeter. So let's suppose 1 centimeter and it is 100 centimeter. Minus 1 by 2. Gram cancel out, centimeter cancel out. So I can write it as 0.5. 1 divided by 10 to power 3. So I can write it as a 100 10 to power 2. It will become 10 to power 4 plus 4. So it will become 10 to power plus 4. So my answer would be now 0.5 into 10. So it came out to be 5. I think my answer is 5 only. My answer is 5 only, right? Okay, we will do one now, last numerical. We will do one last numerical to get this topic done. Okay. Is there any lag now? Is there any lag now? Yes. Is there any lag? Okay, now one more numerical. Convert 1 joule to a system. 1 joule to a system where a unit of mass, length, time r. Hundred gram, 20 meter, 10 seconds. So we have to convert 1 joule. So what is joule? Joule is energy. What is the formula for energy? ml2t minus 2. We have to convert it to a different unknown system of unit in which mass is 100 gram, length is 20 meter, and time is 10 seconds. Now look, we are having 1 joule. Joule is energy. Energy is ml2t minus 2. So N1 is given 1 joule. U1, in U1 my M1 is given, my L1 is given, my T1 is given. M1 is kilogram, we know it now. Length is meter, time is second. Also, my A is 1, B is 2, C is minus 2. Here we are having U2. In U2, my M1 is given as 100 gram. L1 is given as 20 meter. Sorry, it is 2, no? It is M2, L2, T2, and T2 is given as 10 seconds. I think we know the formula that N2 is equals to N1, M1 by M2 power A, L1 by L2 power B, T1 by T2 power C. What is N1? So I can write here now. Why I can just. What is N1? N1 is given as 1. M1 is kilogram. M2 is 100 gram. A is 1. L1 is meter. L2 is 20 meter. B is 2. T1 is second. T2 is 10 second. Power is minus 2. Now, 1. In 1 kilogram, we are having 1000 gram. 1000 gram divided by 100 gram. Power 1. Meter, we are having, okay, it is meter now. We don't need to get it. So this meter get cancel out. So we are having 1 divided by 20 power 2. Second get cancel out. So we are having 1 divided by 10 minus 2. Now look then, cancel out 20 cancel out now. So I can write it as a 1. It is 10. 1 divided by 20, it is 1 divided by 400. And 1 divided by 10, it will be minus 10, it would be 10, it is 100. 20 get cancel out. Now I am having 10 by 4, which is equals to 5 by 2. Therefore, my N2 came out to be 2.5. N2 came out to be 2.5. 2.5. We are having second application part. Second application part, that is to check the dimensional correctness of a given physical quantity. Of a given physical quantity. So that means dimensional formula of left hand side should be equal to the right hand side. If dimensional formula of given physical quantity of left hand side is equal to the dimensional formula of that quantity which is given to us is equal to the right hand side, so we can say that this equation is a dimensionally correct equation. So this equation is a dimensionally correct equation. Okay, and this principle is known as principle of homogeneity. So I can write here, this is known as principle of homogeneity. So one more thing that I want to give here, that is a dimensionally correct equation. A dimensionally correct equation may be physically incorrect. May be physically incorrect. So what is the meaning of this thing now? Suppose we need to check whether the following expression is a dimensionally correct or not. So if we are having P is equals to rho g h, this is a famous equation in the fluid mechanics. Pressure equals density into g into h. So we can divide into two things. First one is the left hand side and that is a right hand side. In left hand side we are having pressure. So pressure is equals to force per unit area. Force is mlt minus 2, area is L square. So what we get, it is ml minus 1 t minus 2. In the right hand side we are having rho gh. Rho is density, density is mass by volume. G is acceleration due to gravity, that is lt minus 2. Height is L. So I can write it as a m L3 L2, that is L minus 3. Okay, 2, not 3. Okay, it is minus 1 and t minus 2. So this is a dimensionally correct equation. And we know this is physically also a correct one. Now look, if we are having one more equation now, that is kinetic equation, kinetic energy equals to 3 mv square. So we know that physically it is physically incorrect. Why? Because we know that kinetic energy is equals to 1 by 2 mv square. This is physically incorrect one. So we need to check whether this is a dimensionally correct or not. So we will take left hand side, we will take right hand side. Left hand side is kinetic energy. It is energy, that is ml2 t minus 2. Right side it is 3 mv square. 3 is a dimensionless quantity, so I can write m is mass, so I can write m. Velocity is lt minus 2 square, so lt minus 2. So it is a dimensionally correct equation. Dimensionally correct, but it is not a physically correct one. Dimensionally correct, but it is not a physically correct equation now. I think there is a lag now. Let's check it out. there is lag in this system, so we need to wait for 1 minute so it gets restored. So we will take a 2 3 minutes break. Okay, 2 3 minutes break. You can take it. So let's start once again. There's a lag, but I don't know why this is happening. Let us start. Firstly, I need to check whether I'm audible or not. Then we will start the lecture. Okay, now. So now we are having third type of application part of it. Okay, we're having third application part of it. Look, we are having now third application part of it. That is to derive relationships to derive a relationship between different physical quantities. Different physical quantities. Suppose we are having a numerical to done so that we can have a very good idea how we can use the equations. Look now, we are having position x. Position x of a particle depends on acceleration a and time t. Find its relation. Find its relation. How we can do it now? Look. So it stated that we need to find out position of a particle, and the position, that means x, is depending on the acceleration a by some a times and the time t by some b times. So now how we can do the numerical? So x is a length. So what is the dimensional formula for x? It is m0 l1 t0. It is equals to, what is acceleration? It is lt minus 2 power a. Time is t, power is b. So now I can write it as a L power A T minus 2B and TB. I think I can write it as a LA T minus 2B plus B. It is equals to M0 L1 T0. We know that principle of homogeneity states that left hand side is equals to right hand side. So my A is equals to 1 and minus 2b plus b. That is minus 2b plus b, right? Yeah, it is minus 2b plus b. I can write it as a how much? It is minus 2a. It is minus 2a. Minus 2a plus b. It is here a. Here we are having a. So it is minus 2a. Minus 2a plus b. It came out to be 0. A is 1. It is minus 2 plus b is equal to 0. So b came out to be 2. So therefore, my x is proportional to a to the power 1, t to the power 2. Or I can write it as a x is equals to k, a power 1, t power 2. In this way we can do it. Okay, one more. One more. Now look, we are having a numerical which states that if pressure, which is P, velocity V, and time T are taken as base quantities, then find the dimension of force. We need to find the dimension of force. But how we can do it now? It stated that my force is depending on pressure by A times velocity by B times time by C times. My force it is equals to mlt minus 2 equals to pressure. So I think pressure is ml minus 1 t minus 2 power A. V is velocity, velocity is lt minus 2 power B. Time t, t is power C. So I can write it as a m a l minus a t minus 2 times a lb t minus b tc. It will be equals to m power a l minus a plus b t minus 2a minus b plus c. Left hand side we are m1 l1 t minus 2. We can what we can do then, look, now we are having a, so a is equals to 1 minus a plus b is also equals to 1 minus 2a minus b plus c is equals to minus 2. So if a is equals to 1, so I can write minus 1 plus b is equals to 1. So I can write b equals to 2. A is 1, b is 2. So what is the c then? What is the value of c then? So it is minus 2 into 1. B is 2 plus c equals to minus 2. It is minus 2 plus c equals to minus 2. Minus 4 plus c equals to minus 2. C came out to be minus 2 plus 4. So c equals to plus 2. So therefore, not here, it's 2 to right. So I can write now this equation, this one now. So F is proportional to P. What is A is 1. V, B is 2. T, C, what is C? C is 2. So F is equal to some constant K. P1, V2, T2. This one is the final answer of my question. Now we are also having some kinds of limitations of it also. We are having some limitations of it also. So I can write limitations of dimensional analysis. Limitations of dimensional limitation of dimension analysis. First limitation of it. So we know that if we are only having 3 mlt, if my quantity is depending on only mlt, if my it is depending on mlt only, so we can do it. If more than 3, if more than 3, we can't do it then. We know that now if let us suppose my some quantity x is depending on a, is depending on b, is depending on c, is depending on d. So that means now we are having four equations on right hand side, and left hand side we are only having three equations. So it would be impossible for us to get four variable solution from three equations. So we know that if we want a value of our variables, so the number of variables should be equal to the number of equations. So here you can easily say that the number of variables are greater than the number of equations, so it is next to impossible to get solved. Number two, if we are having some addition type, so let us suppose s is equals to ut plus 1/2 of at square is the addition type, so we can't solve it. We only can solve the multiplication one. If there is something in addition, we can't solve it. Number three, if dimensional if dimensionless quantity is present, if dimensionless quantity is present, we can't derive the dimensionless quantity. Let us suppose we are having 1 by 2 mv square. We can derive mv square, but we can't derive the 1 by 2. So it doesn't give any idea regarding whether it is a scalar quantity or a vector quantity. It doesn't give any idea about it. Clear? So many physical quantities have same dimensional formula. Just like we are having work, right? So we are having torque, we are having work. So these are a same dimensional formula, but we can't differentiate between these two on the basis of my dimensional analysis. Okay, now we are having significant figures. We are having now what? Significant figures or significant digits. Significant figures or significant digits. So significant figure or significant digit is a measurement. It is a measurement in which we are having certainty. Certainty plus one uncertain digit. One uncertain digit. That is last digit. So the summation or the combination of certainty and the one uncertainty is known as significant figure. Let us suppose we got some sort of stick from the market. On the sometimes when we are measuring its length, we came out to be 14.5 centimeter. And in second calculation, we got L2. L2 came out to be 14.4 centimeters. Then we got L3, which came out to be 14.6 centimeters. That means 14 is a certain digit. 14 is certain, but last one is a uncertain. Combination of these three, I can call it as a significant figure. So if my length is, let us suppose, is 14.512. So these are significant, and this one is this one is a certainty, last one is uncertainty. The combination of both two are known as significant figures. Clear? Now we are having rules for it. Rule number first. Rule number first is a non-zero. Non-zero is significant. That's why we are having 1, 2, 3, 4 digit leaking. So I think we are having four significant figure FF. Rule number second. If we are having 1, 0, 2, 0, 3, that means if the 0 is between the non-zero digit, those are also significant figures. So my 1, 2, 3, 4, 5. So we're having five significant figure in this particular measurement. Rule third, if we are having something 0, 0, 1, 0, 8, the zero to the left of my non-zero digit is a non-significant. So only 1 to 3, three significant figure. Rule number 4. If my number is less than if my number is less than what? 0, that is my point something. If my number is less than 1, very small digit, so I can write it as a, so I have 0.002308. How many significant figure are present? Only 1, 2, 3, 4, four significant figure. Rule number 5th. If we are having 1, 5 or 1.580, all the numbers are significant. 1, 2, 3, 4, so four significant figure. We are having rule number 6. 7800. So this is a only two significant. Two significant. Rule number 7. If something is written on the right hand side, some unit. So if I can write 7800 meter. So meter is there, then there are 1, 2, 3, 4, four significant figure. This is how we can calculate significant figure. Now we are having rounding off. We are having a rounding off. What is rounding off? So if in our calculation there is more than 2 to 3 or 4 uncertainty present, if my in calculation in measurement more than one uncertainty is present, and if we want to get it to the specific significant figure, so how we can do it now? So we are having some rules. Also we are having some rules to get it done, in which we are having rule number first. We are having rule number first. I think there is a blur, no? Let me check it. Let me check. I need to check it out now. Give me a second. Okay, now it gets clear, right? Now we will do the rounding off. We will do some rounding off things. Okay, now, so we are having rules to get it rounded off. Now, rule number first, if the digit that we want to get round off, okay, if we are having some digit a and we want to get it round off, and the digit a is less than 5, or rule number 4, that is more than 5. If it is more than 5, if it is more than 5, and if it is a more than 5, then what we can do, the preceding one, the preceding digit, the preceding one, what we have to do, plus 1. We have to increase the preceding by 1. Rule number second, if my number is less than 5, then preceding one unchanged, preceding one unchanged. Rule number third, rule number third, if my a is equals to 5, a is equals to non preceding one, if my preceding one is even, it could be odd also. If it is odd, then plus 1. If it is even, unchanged. Unchanged. Let's take some examples to get it clear. First one, my number is 7.1082. We have to round it off up to 4, rounding off up to 4. Round off to 4 significant figure. Up to 4 we have to round it off, right? So up to 4 means 1, 2, 3, 4. Up to this number we have to round it off. So 2, we need to round off 2. So what preceding digit we are having before 2, that is 8. So is 8 greater than 5 or less than 5? It is greater than 8. So we have to, so it is greater than 5 now. So we have to plus 1. So do plus 1. So it will become now 7.109. Same way, second one. If we are having 65.837, a round off up to 4. It is 1, 2, 3, 4 like this. 7 greater than 5 to plus 1. It will become 65.84. 3. We are having 3.1251. Rounded up to 4. 1, 2, 3, 4. Now we are having 51. I think 51 is greater than 50. So we have to increase it by 1 plus 1. So my answer becomes 3.13. If my digit is now 3.125. Now, so we have to round it up, but number 5 is equals to 5. So we have to look into the preceding one. My 2 is an even. If it is an even, then we have to take it as it is now, plus 0, unchanged. So it is 3.12 only. Fifth one, if we are having 3 point, let's say 135 now. It is 135, right? So 4 is up to this one. So 5 and 3 is odd. This one is odd, this one is even. If odd, then plus 1. So it becomes 3.14. So we can do the significant figure like this. Now we are having Rules. First one rule is addition and subtraction. Addition or subtraction. Addition or subtraction. So we have to place decimal on decimal, right? So it is, if it is 51.49, we have to add this thing with 7.200. I think my answer came out to be 51. It is 58. It is 58.4 690. But here up to this digit we are having 2, we are having 3, so we have to choose this one now, up to 2. So we have to do up to 2 only. It is 0, 0 is even, so I can write 58.69 only. So my answer is 58.69 only. Okay, now one more. If we are having a digit like 12.587 minus 12.5, its answer would be equal to 0. It is 0.087. Up to decimal we are having 3, we are having 1, so we have to do up to 1 only. So up to this only. This digit is greater than 50, so we have to increase the preceding by 1. So my answer will be 0.1. One more. If we are having 34.663 minus 2.41, so my answer would be 32.253. Now here 3, here 2, I had to choose 2, that up to this one only. This digit is less than 5, that is unchanged, so it is 32.25 only. This is my answer. Now I am having multiplication and division. Rule second. Multiplication and division. Multiplication and division. So let us suppose I am having 2.0 multiplied by 42. It will be equals to 4 to the 8. It will be equals to 84.0. Two significant figure. 2, right? So my answer will be 84. So I don't need to look into the decimal point now. In addition or subtraction, my only focus was to have the decimal knowledge. In right side of the decimal, how much significant figure I was having, so I need to get around up to that one. Now in multiplication division, the whole scenario I need to take into consideration. So if my second one is 8.50 multiplied by 2.000, 3 4, my answer is 17.123. So it can be done up to 17.0 only, up to 3, right? Now we will start the errors, the last portion, part of our syllabus. Errors. What is error? What is error? Error means uncertainty. Uncertainty in calculation. Calculation or measurement. Uncertainty in calculation or in measurement is known as errors. Okay. We are having types of errors. Types of errors. First error means systematic error or controllable errors. These are those errors, and in these errors we are having three topics here. One is instrumental error, one is instrumental error, second one is the environmental error, environmental error, third is the observational error, observational error. Instrumental error means if we are having some defective instrument with us and we are calculating any measurement by using that instrument, so we will get an error caused by that instrument known as instrumental error. Environmental means if we are having doing some kind of environmental sensitive calculation. Let us suppose we are measuring something, but that device is getting interpreted by some humidity, by wind, by temperature, and all these kind of stuff. So we will have an error in it. It gets because of the environmental condition. So we call it as the environmental errors. Observation means if we are having some carelessness in noting down some errors, if we are doing some errors and we have to read it and calculate it, but we are not very careful to note it down, so the errors which came just because of the our observational things, so we can call it as a observational errors. Now we are having second type known as random error, known as random error. A random error means whose cause unknown. Cause unknown. If cause unknown, then we cannot minimize it. We don't know the reason of the cause behind it, so it is unknown to us. But we can reduce it. If we can do the same thing by couple of times, so we can reduce it. Okay, by taking the observations many times, we can reduce it. Number third, we are having gross error. We are having gross error. What is a gross error? Gross error is that error which came out because of the human carelessness. Human carelessness. Okay, this is a human error. Now we are having thing known as representation of error. Representation, representation of errors. Representation of errors. First thing, absolute error. Delta A. Delta A. It is an absolute error. So absolute error is nothing but true value minus measured value, minus measured value. If you are buying something and you are having some value on it, so that value is the true value, and when we are measuring it, that is the measured value. So I can write it as a delta A is equals to true value of it minus measured value of it. If true value is not given, if true value is not given, then how we can find the true value? So I can take the mean of all measured value, mean of all the measured values. I can take it like that. Just like I can take is 1 by n summation from to 1 to n of ai, which is equals to I can take a1 plus a2 plus so on up to an divided by n. Let us take an example of it. The length of something is given as a 10.0 centimeter. That means this is a true value. This is true value. This one is true value. And my first calculation came out to be 10.1 centimeter. My second came out to be 9.8 centimeter. So in first scenario, my delta A1 came out to be 10.1. It would be equals to how much? 0.1, right? Minus 0 fluid errors divided by n. Then we are having fractional or relative error, or relative error. Fractional or relative error. It is equals to mean absolute error. Mean absolute error whole divided by true value. So we will delta AM divided by 80. Then we are having percentage error. We are having then percentage error. Percentage error means relative error. Relative error multiplied by 100%. Or mean absolute error. Mean absolute error whole divided by true value into 100%. Here we are having 100%, not 10. Let's take one numerical so that we are having full confidence on this topic. Now look. So we are measuring some length of the rod, and measurement came out to be like 4.01 centimeter. Second came out to be like 3.99 centimeter. Then 4.06 centimeter. So these things we got, but we don't know the actual, that what is the true value of that thing. If the true value is not given, then we have to take the mean of all these values. Okay. First thing, true value. How I can get the true value? So I can get 4.01 plus 3.9906 whole divided by 3. I will get 4.02. 4.02 is a very relative one, or I can say it is a true value. Second one, how I can get the absolute error. Absolute error. So we have done three calculations, so there will be three absolute errors. This delta A1, which came out to be 402 minus 4.01. Second delta A2, the third delta A3. It is 4.02 minus 3.99. Then it is 4.02 minus 4.06. In first case, we are having 0.01. Second case, we are having 0.03. Third case, we are having minus 0.04. Absolute errors. Now, third one, what is mean absolute error? Mean absolute error. Third one is mean absolute error. Mean absolute error. So delta A1 mod of it. Okay, so I can write it as a delta A1 plus delta A3 whole divided by number of things, that is 3. So I can write it as a 0.01 plus 0.03 then plus 0.04 whole divided by 3. 448, it is 0.08 then. Okay. So it would be approximately how much? 0.03. Now we are having mean absolute error, then we are having relative error. Fourth one. We are having a relative error. We are having relative error. So my relative error is nothing but it is a mean absolute error divided by true value. So it would be 0.03 divided true value is how much? 4.02 error. We are having percentage error, and percentage error is I think 0.03 divided by 4.02 into 100%. In this way we can calculate these things, right? We can calculate these things. Okay. Legend चल रहा है lag, इधर any lag? I don't know. I just now we are having addition of errors. We are having addition or plus minus 0.1 centimeter, and B is given as 4.1 plus minus 0.2 centimeter. I need to find out displacement. I think displacement is nothing but B minus A. What is B? So I can do separately. I can do this one only. It is 4.1 minus 6.4. Then plus minus errors only 0.1 plus 0.2 only. Every time my errors get added up, not subtracted. So it would be equal to how much? 4.1 6.4. It would be equal to minus 2.3. It is plus minus 0.3. This is my answer. Now we are having multiplication. And we are having division. Multiplication and division. So if I'm having quantity x and equals to a to the power p to the power q c to the power r, so my delta x by x fractional error, it came out to be p delta a by a plus q delta b by b plus r delta c by c. This is my representation of it, and it is valid for the small error only. Okay, I will take an example to get it clear. I'll take an example of it. Example is like if my error in A is given by 1%, B is given by 2%, C is given by 4%. So my question is P is equal to A square B power 3 C power 1. What would be my the percentage error in my P? So I can write delta P by P into 100. It could be equal to percentage 2 delta A into 100 plus 3 delta B by B into 100 plus 1 delta C by C into 100. So this thing is given to us. These things are given to us. It will be 2 into 1%. 2 into 1% plus 3 into how much? It is 2% plus 1 into 4%. So 2%, 6%, 4%. It is 12%. My error came out to be 2%, 2%, 2. It is given as 4%. That is 9%. My error is a 19%. And there is a lag. I don't know the reason behind it, but I won't stop now. One more. If I am having A which is equals to 2.0 plus B which is equals to 1.0 plus minus 0.2, and I need to get this one clear, P equals to AQ plus B square. Now look, this type is a addition also in the exponent also. Addition plus power. So we have to get this one clear, we have to differentiate it now. So how I can do it now? It is dP by dP equals to, it would be A, right? So I can get it the difference. It would be A, right? So I can get it the differentiation of A cube with respect to dP. So the differentiation of B square with respect to this one. So it can cancel out. So I can write dP equals to dAq plus dB square. So I can write dP, right? I can write it as a 3 A square dA plus 2B dB. So 3 is 3. What is A? A is given as 2, no? It will be 2 square. Don't know. 2. What is B? B is 1. And dB we don't know. I need to find out on dB now. So this is out on dB now. So this is A, this is dA, B, dB. So how I can get it now? So it would be 3 is 0.1 plus 2 into 1 dB is 0.2. So I think my answer would be 4 is 12, 12, 1.2, 1.2 plus 3, 3.2, 3.2, 4, 4, 0.4 into 1.6. So my dP came out to be 1. But what I need now, I need P plus minus dP. So what is P now? What is P? P is this one, no? What is P? P is this one, no? It will be 2 cube plus 1 square. 8 plus 1, that is 9. It will be 9.0 plus minus 1.6. Now we will do a last numerical and we will conclude this portion. Okay. Last numerical. Last numerical like, I will write this one in a very good way. Mass gets changed by 1%. Velocity by 2%. Then what would be the change in kinetic energy? We know that kinetic energy to 1 by 2 mv square. So I need to find out the change in the kinetic energy. So I can write delta kinetic energy divided by kinetic energy multiplied by 100%. It will be equals to delta into 100% plus 2 times delta V by V into 100%. This thing is given to us, this is 1% plus 2%. It equals to 5%. Okay, it is a 4% thing. Now we are done with the instruments only, so we can conclude the instrument in the instrument chapter. Okay, the list count on all these kinds of things. So we have completed. This one. So we topic of this chapter, that is units and measurement. We have done a very good numericals also. We have came from 0 to the 100%. We have done each and everything here. We have not missed a single topic with a single numerical portion. We have concluded and we have completed everything, right? If you want the notes, if you want something else, so you have to join my Telegram channel, and the link of the channel is given. It's associated with my YouTube channel. Thank you very much, and bye. Take care and good night. Okay. So how was it? The lag is going on continuously. And thank you. Bye.